Our next speaker is Christopher Adigun from Amazon, and he will present the OAI 5G user plane acceleration using Amazon Web Services EKS, where I don't know what EKS means, unfortunately. So please start with that.
Hi, so my name is Christopher Adigun. I work with Amazon Web Service as a telco solution architect. So for the demo, I'll be presenting deploying OAI 5G user plane acceleration using AWS Elastic Kubernetes Service. So EKS is there Amazon's Kubernetes managed service. Okay. So EKS stands for Elastic Kubernetes Service. So that's our managed Kubernetes service that helps you to deploy your Kubernetes application. So the agenda goes thus. We'll be looking at the architecture. Okay. Sure, it's changing.
Oh, yes, well, sorry.
So during the demo, we'll be seeing, first of all, we'll be looking at the architecture, like the 5G core architecture, the flow from the RAN up to the way to the core. And then we'll be looking at also how to prepare the worker node, which is for the Kubernetes aspect also, because you require to install the DPDK drivers. And then we'll be looking at how do you inject the DPDK interfaces into the UPF port. And then as an addition to what we have, compared to what you can see from the tutorials we have from OpenAirInterface website, I'll be using the Flux CD to do the actual deployment. So instead of doing the manual Elm install, so there will be a controller that will be installed in the Kubernetes cluster. And then we'll be looking at how to inject some sample UEs into the UPF and then do the load testing. So like I said, this is the architecture that will be following. So a quick difference from what you see from what you see in the normal OAI 5G core tutorial would be that the MySQL is actually abstracted away from the Kubernetes cluster. So I'm making use of the relational database service that we do for MySQL database. And then also the ECR, that's the Elastic Container Registry, will also be used not only for the container images, it's going to be used also to store the actual Elm charts. So that's why you have the arrow that goes to the Flux CD Elm controller. Then another addition to that will be the CG NAT. So the CG NAT will that's the carrier grade NAT. I'm also using a VPP instance also for that, not just for the UPF. And then so two validations we'll be doing will be with the normal UA ransom and also with the load testing, which will be using Trex and also a PFCP simulator. And lastly, this is just a sample of the throughput that I did and some statistics that we were able to get when we did some tests for the VPP UPF. So this is not the maximum these instances can do, but during the demo we can drill down to see how we can increase this performance. But basically, this performance is based on there is a current limitation with the UPF plugin in that it cannot support multi-queue. But once you have the multi-queue support, you can actually have much more packet per second and the throughput also in gigabits. So that would be it. Thank you.